The overall goal of this procedure is to fabricate and investigate metal lanthanum aluminate strontium titanate heterostructures using a combination of pulsed laser deposition, magnetron sputtering, X-ray photoemission spectroscopy, and magnetotransport experiments.
This method can help answer key questions about the interplay between electrostatic and chemical phenomena of the quasi-two-dimensional electron gas formed in these types of systems. The main advantages of this technique are its simplicity and versatility, which together allow high-quality layer-by-layer growth of multiple ultra-thin films.
First, fill a 40 kHz ultrasonic cleaner with water and heat the bath to 60 degrees Celsius. Add to a borosilicate glass beaker sufficient acetone to fill the beaker to at least 20% of its maximum volume. Place in the beaker an out-of-the-box mixed-terminated single-side polished 001-oriented STO single-crystal substrate. Sonicate the substrate in acetone for 3 minutes. Dry the substrate under a stream of nitrogen gas from a blowgun. Repeat the sonication in isopropanol and deionized water in sequence. Mount the clean substrate in a polyvinylidene fluoride dipper. Fill another borosilicate glass beaker with flowing deionized water. Then fill about 20% of a similarly sized polytetrafluoroethylene beaker with hydrofluoric acid buffered with ammonium fluoride. Use the dipper to immerse the substrate in the buffered oxide etch for precise